All right, let's begin. Today, we're going to start chapter 6, section 2. We did section 1 last time. We're going to start solving equations now. Section 2 deals with linear equations in one variable. Remember what a linear equation was. It's an equation of a line, hence linear. Only has at most one solution. The x does not have anything on it, like absolute values, square roots, cube roots. It's not 1 over x, and so on and so forth. It's just x. If you guys want to, you can turn the light off if it makes it easier to see. Just press it. Is that better? So linear equation is an equation of a line. Only has at most one solution. The x does not have anything on it, above it, around it. It's just x. You moved. It's one of these movable ones.
Oh,
So that's what linear equations. That's what we're dealing with in this chapter. Pretty much, eventually what you'll see in mathematics that if x has any exponent, any power, this power tells you the maximum number of solutions possible. So if you have an x in an equation, the exponent tells you the maximum number of solutions possible. Since in our equations, x has a number, it's just x that has number 1 on top of it. That means it only has one solution. Which goes to ask, when we say solutions, what are we talking about? Solutions have multiple names. They're also called roots, factors, x-intercepts on the graphs. Those all mean the same thing. They're synonymous, they're interchangeable. A solution is the value of the variable that makes the equation true. So a solution is the value of the variable that makes the equation true. Good morning. Okay, in this, what does equation mean? What is an equation? We have two types. We have equation and we have an expression. What's the difference?
Expression is no equal and
So that means an equation has an equal sign. In an equation, you solve for the variable. You get it by itself equals some number. That's the solution. This number here is a solution. So an equation has an equal sign and you're asked to solve for the variable. You'll end up with this: x equals, or the variable equals some number. And that number is the actual solution. An expression has no equal sign and you simplify. And you simplify it. You simplify it by combining like terms. Yeah, that should be better. So whenever you see, what's that? It's abbreviated. Yeah, it's supposed to be combine. I put the G too early. Combining like terms. Good catch. Combing. It's combing. You have to comb it. You have to groom it for a right answer. All right, so solutions are just that. It's the values that make the equation true. In other words, when you plug it back in there, both sides equal each other. For example, let's look at there's an equation. It's got an equal sign. It's got a variable. So therefore it's an equation. So the objective here is solve for x. That's your objective. Whenever you see a variable and an equal sign, that's your objective. Here are the steps. We're going to build up on these steps as we go through these examples. First step. Move all x's to one side of the equal sign. Check. All the x's on one side. Move all non-x's to the other side. Of the equal sign. Move all non-x's to the other side by a process of opposites. Remember, we're going to keep on adding to this as the examples change. We solve these in the opposite order of the order of operations. We solve these in the opposite order. In order of operations, you would do multiplication first before you do addition or subtraction, right? But when you solve for x's, you do it the opposite. You have to tear them apart. So the first thing you have to get rid of is anything plus or minus to the x. We do it by opposites. What's the opposite of positive 4? Negative 4. So we put negative 4 on both sides. Positive 4 minus 4 cancel out. 9 minus 4 is 5. So there is your answer. Step 3 is isolate the x and then check your answer. I'll simply abbreviate it CYA. So x equals 5 is our solution. Our solution set is the number 5 in brackets. Remember in the first part of this course, when we talked about sets, data sets, we had them in brackets. You do the same thing in mathematics. That's where it came from. Let's check your answer. Always start off with the original equation when you check your answer. Can you tell me why? Because that's the only thing that hasn't been touched by you. It's exact. Anything after that, anything that you do to an equation changes it. If you did something wrong, it'll be wrong all the way through. But the only thing that hasn't been changed or touched is the original equation. So we're saying that x equals 5. Anywhere we see an x in this equation, we put 5 in its place. 5 plus 4 is 9. 9 equals 9. So that tells us, so x equals 5 is the solution. We're gonna start building up on these equations, making them bigger and more complex. But this is the first one. Let's take another one. Five x minus 4 equals 6. Tell me the solution and the solution set. So what's the first thing you do? Yeah, since there's all the x's on one side already, we have to get rid of the plus minuses. So we have to do the opposite, +4 both sides. -4 + 4 cancel out. 6 + 4 is 10. Now what?
Divide by 5,
Why divide?
so you can get the x.
Yes, because 5 is attached to x by multiplication. The opposite of multiplication is division. So divide 5 to both sides. 10 divided by 5 is 2. And we check the answer. So anywhere I see an X, I put a 2. Order of operations, 5 times 2 is 10. 10 minus 4 is 6. So since that's true, that's the right answer. All right, let's look at a bigger one. I think you guys can do this. Let's look at the steps. What's different about this one, the ones we did earlier? Well, it's got parentheses, right? So the first thing is get rid of parentheses. By distributing. So positive times positive is positive. 3 times x is 3x. Positive times positive is positive. 3 times 4 is 12. That's the first one. So minus 12x. Positive, positive is positive. 2 times 3 is 6x. Positive times positive is positive. 2 times 5 is 10. Whenever you get rid of parentheses, the first thing you do is combine like terms. Whenever you get rid of parentheses, always combine like terms. So the x's are the like terms. So we have 3 minus 12 equals what? Yes, since 12 is bigger, the answer is negative. 12 minus 3 is 9. X plus 12 equals 6x plus 10. So we got rid of the parentheses. We combined like terms. Now we see we have x's on both sides. What do you do next? Remember, always move the x's first. Don't worry about the numbers. Always move the x's first. Which one do you move? Why? But you're right, it is. It is -9. Always move the smaller x to the larger x. So the answer will be, or not the answer, the coefficient will be positive. If you move the smaller to the larger, you'll always have a positive in front of the x. Because if we move the 6 over there, how do we move the 6? It's a positive 6, so we have to do what? Subtract 6, so we'll have a negative 15. I'll show you what to do if you have a negative in front of the x at the end, but we want to avoid negatives if we can. So negative 9 is smaller than 6. How do we know that? How do we know negative 9 is smaller than positive 6? Because it's, yeah, negative 9 is to the left of 6 on the number line. Whatever's left is smaller than whatever's right. So we're going to move the negative 9. How do we move the negative 9? Add 9 to both sides. Six plus 9 is 15. Plus 10. Move all non-x's to the other side. So we have to get rid of the 10. How do we get rid of 10? Minus 10. Positive 10 and negative 10 cancel. 12 minus 10 is 2. Equals 15x. Then solve for x. We have to get rid of the 15. Since it's multiplied, we have to divide the opposite. 15's cancels. We have x equals 2 over 15. So far, so good? Yes, you could check your answer. I'm not, but you can. So always, whenever you have parentheses, get rid of parentheses first, combine like terms, move the smaller x larger. It's always the same procedure. It's 10x equals negative 10. All right, let's see. First step, we have parentheses, so we have to get rid of them. Well, first off, can we do anything inside the parentheses? No, so we have to get rid of them. 6 times x is 6x. Positive times negative is negative. 6 times 3 is 18. Minus 10x equals negative 10. So we got rid of the parentheses. The second step is combine like terms. 6x minus 10x. Since 10 is bigger, negative 10 minus 6 is 4. X minus 18 equals negative 10. All the x's are on one side, so we have to get rid of the non-x's. We have to get rid of the negative 18 by adding 18. There's negative 4x. 18 is bigger than 10, so the answer is positive. 18 minus 10 is 8. All right, here's where a lot of y'all will make a mistake. I don't say mistake, it's not wrong, But the chances are making a mistake at this point are greater than ever because you have a negative. This is my personal preference. You can use it if you want to, but I like to remember, I like to treat signs and numbers differently. Because I don't want to mess up with the signs to my equation. So. If X is negative, change the signs of each term on both sides of the equal sign. What you're really doing is you're multiplying by -1 across the board. Whatever you do to one side, you can do to the other, it keeps equality. So I'm changing this sign and I'm changing this sign. And then I divide by 4. The answer is going to be negative. 8 divided by 4 is 2. Let's check the answer. So anywhere I see an X, I put a -2. Inside the parentheses, -2 minus 3 is, since they're both negative, the answer is negative, add the numbers. Now multiply. Positive times negative is negative. 6 times 5 is 30. Negative times negative is positive. 10 times 2 is 20. 30 is bigger than 20 and it's negative, so the answer is negative. 30 minus 20 is 10. It's a true answer, so that is your answer. That X equals 2 is your solution. So X equals -2 is your solution. Want to do another one like that? Okay. Let's do another one. 2x minus 3 minus 17 equals 13 minus 3 x plus 2. All right, let's take a look at this one. We can't do anything inside the parentheses, so I get rid of them. 2 times x, 2x. Positive times negative is negative. 2 times 3 is 6. Minus 17. Equals 13. Negative times positive is negative. 3 times x. Negative times positive is negative. 3 times 2 is 6. We got rid of parentheses, so the first thing we have to do is combine like terms. Those two and these two. They're both negative on the left side, so we add them. 17 plus 6 is 23. negative 3x. So we have 13 positive and negative. 13 is bigger than 6. So answer is positive. 13 minus 6 is 8. Is it? No, 7. 7. So we combine like terms. And actually, after we finish this, I'll show you a shortcut at that stage. Remember, always move the x's first. So which x do you move? The smaller one, the negative one. If they're both negative, if the number's negative, the bigger the negative number, the smaller it is. This is farther to the left. So we have to get rid of negative 3. So we add 3x to both sides. Threes cancel. 2 plus 3 is 5x minus 23 equals positive 7. All the x's are on one side. So we have to get rid of the negative 23 by adding 23 to both sides. Both positive, so the answer is positive. 23 plus 7 is 30. Nothing else around the x, so we get rid of the 5, divide both sides by 5. So x 30 divided by 5 is 6. I'm saying that's my solution. So now I'm going to check my answer. Go back to the original equation. And anywhere I see an x, I put a 6. So we have 2, 6 minus 3. 6 plus 2. Do inside the parentheses first. You notice it's different process. When we're solving equations, we follow the order of operations when we're checking them out. But when we solve for the x's, we go the opposite direction. 6 minus 3 is 3. 6 plus 2 is 8. We have parentheses, we get rid of those. 2 times 3 is 6. Minus 17. 3 times 8 is 24. 7, they're opposite signs. 17 is bigger, so the answer is negative. 17 minus 6 is 11. 24 is bigger than 3, so the answer is negative. 13, I mean. So the answer is negative. 24 minus 13 is 11, so it works. What do y'all think? Getting better? Let's now change the way we do things. That looks easy enough, right? If you have fractions and an equal sign, then get rid of the fractions. So if you have fractions and an equal sign, get rid of the fractions. How do you get rid of the fractions? First, find the LCD, the least common denominator. In our case, the LCD is what? It's 5 times 2, which is 10, because it's the two bottom numbers, since they're both prime numbers. Step 3. Multiply the LCD to each term. In other words, just put a parenthesis around each term. And put the LCD in front of it or behind it, doesn't matter where. So we found the LCD, we multiply the LCD to each term. Before you multiply, whenever you're multiplying fractions, always reduce first before you multiply. So can anything cancel top and bottom here? This is actually 10 over 1. This is 10 over 1. So can anything cancel here? The 2 goes into the 10 how many times? Right. And the 5 goes into the 10 2 times. And there's nothing here. Yes, now you see why the LCD is made up of everything on the bottom, because our entire goal is to get rid of the bottom number. So this is what we have now. Which one's easier to look at and deal with, top or bottom? They're exactly the same equations. It's just that we got rid of the fractions. So that's the whole process. Now we solve it like we've normally been solving it. Step 5. Multiply to get rid of the parentheses. Five times 3 is 15x. 2 times 8, 16x. Negative positive is a negative. 10 times 4 is 40. And once you get rid of the parentheses, solve for x. How do we solve for x? We have x's on both sides, so which one do we move? Right, the smaller one. Which one's smaller, 15 or 16? So we move the 15, subtract 15x from both sides. 15 minus 15 is 0. 16 minus 15 is 1. So it's one x or x minus 40. It's perfectly legitimate to have a zero as one side. Get rid of the negative 40 by doing the opposite. Add 40 to both sides. So x is equal to 40. Check your answer. 3x over 2, 8x over 5. Here's a note about fractions. 8x over 5 is the same thing as 8 over 5x. So if you have an equation that looks like this, you can just move the x to the top number. These mean exactly the same thing. So anywhere I see an x, I put a 40. So 3 times 40 over 2 equals 8 times 40 over 5 minus 4. Whenever you have fractions and multiplication, always do reducing first before you multiply. Always reduce first before you multiply. So in this first equation, can anything cancel? Doesn't 2 go to 40? 2 goes into 40 how many times? 20. 5 goes into 40 how many times? 5 times what is 40? 8. So this is what we have so far. Three times 20, 3 times 2 is 6 with a 0. 8 times 8 is 64. 64 minus 4 is 60, and it works. So x equals 40 is our solution. Do another one. Actually, I'll make one up. There. And let's put some more stuff in there. There. So that's an x plus 4. My hand got tired. Good afternoon. So we have fractions and an equal sign right there. So what's the LCD?
15.
Because 5, 3, and 15 all fit into 15. Multiply the LCD to each term. This is a term. This is a term. That's a term. And that's a term. Anything separated by plus, minus, or equals. So we have 4 terms in this one. 15 times 4/5x plus 15 2/3 times x plus 4 equals 15 times 1 minus 15 times 7/15 times x minus 2. I'll just put 15 in front of each of these terms. Reduce or cancel. Does 5 go into 15? How many times? And 3 goes into 15. 5 times. 15 goes into 15 once, so it's gone. Since all the bottom numbers are gone, this is all we have left. Since that's a 1, I don't have to put anything there on the last one. Fourth step is multiply to get rid of the parentheses. Three times 4 is 12x. We have 2 sets of parentheses here, so 5 times 2 is 10. X plus 4. 15 times 1 is 15. Negative times positive is negative, 7x. Negative times negative is a positive. 7 times 2 is 14. I still have parentheses. Positive, positive is a positive. 10 times x is 10x. Positive, positive is positive. 10 times 4 is 40. There, all parentheses, all fractions, everything's gone. Whenever you get rid of parentheses, what do you always have to do? Combine like terms. So 12x plus 10x is 22x plus 40. There, 15 plus 14 is 29 minus 7x. And the last step, solve for x. All right, so far so good. Is everybody okay with what I'm doing so far? Did I lose anybody? So I have x's on both sides. Which one do I move? The negative number. I always move the smaller to the larger. So I add 7x to both sides. Always move your x's first. Those are the most important ones. You always want to make sure you have a positive coefficient on your x's. That's why you move the smaller to the larger. 22 plus 7 is 29. Plus 40 equals 29. There's only one x in this whole equation. So on this side, so I have to get rid of the non-x's. It's a positive 40, so I have to subtract 40. Since 40 is bigger than 29, the answer is negative. 40 minus 29. Zero minus 9, you can't do it, so you got to borrow 1. 10 minus 9 is 1. 3 minus 2 is 1. So the answer is negative 11. Since you're solving for x, we have to get rid of the 29. Since they're multiplied, we got to do the opposite and divide both sides by 29. And I'll say that's the answer. All I did there was combine all the rules all the procedures we've been talking about for the last 40 minutes, last hour, actually. Yeah, and each step, you see what I did? I didn't try to cram too many things in one step. It's cheaper to buy a ream of paper than it is repeat this course. So don't put everything in one step and make a careless error. Treat the signs and the numbers differently. Let's do a quick recap of this part. I'm sorry, you're still looking at it? You're still looking at it? Yeah, okay. Let's look here. Let's say we had let's look at these 4 operations. Because these are the only things that can happen to you in these equations. The first one shows you that if you have the x variable with a minus sign behind it, how do you get rid of the 3? You have to add 3. So you get x minus 3 equals 5. You have to add 3 to both sides to get x by itself. If you have a plus sign after the x, or in front of the non-x term, we have to subtract 7 in this case. So x plus 7 equals 9. So we have to subtract 7 from both sides. But if you have something multiplied to x, how do you get rid of that? How do you get rid of the coefficient? Divide by the coefficient, which is 3. So 3x equals 9. I have to get rid of the 3, so I divide by 3, both sides. If I have a number below x, how do we get x by itself? What do I have to do here? Yeah, it's the opposite. This is division. I multiply by whatever the denominator is. So I have x over 2 equals 3. I multiply both sides by the denominator. The 2's cancel. Good. When you solve for x, it's always a process of opposites. So in this last column, let's write those as solution sets. These are my solutions. This is the procedure. This is the initial equation. This is my solution set. Since this is a linear equation, meaning it only has one answer, x equals 8. So my solution set is 8 in brackets. This is a linear equation, meaning I only have one solution. And in this case, it's 2. And likewise, those are your solution sets. So far, so good. We have one more topic to discuss. It's pretty quick, actually. It's called proportions. I know you've heard it. What are proportions? What does a proportion look like? A proportion is when you have two fractions that are equal to each other. For example, one over 3 is equal to 3 over 9. True? Why? Very good. Because 3 over 9 is 3 times 1. 9 is 3 times 3. We can cancel the 3's. So 1/3 equals 1/3. They just look different. So that's what a proportion is. Now, the easiest way to check if the proportion is true, because yes, you could prime factorize all of them, but that's a lot of work. Let's look at this example again. 1 over 3 equals 3 over 9. To check, cross multiply. Cross multiply. Multiply these two together and multiply these two together. So 1 times 9, does it equal 3 times 3? Since that's equal, that means this is a proportion. So using this general rule, A over B plus C over D, using the cross multiplication, I get, if this is true, then that has to be true. So you can put this in if then. If that's true, then that's true. Solve for X. We'll do 2, 3, or 4 of these equations, examples. Okay. So let's look at the first one we just talked about. So if we cross multiply 63 times 5 equals 7 times X. Don't multiply these because you're solving for X. So let's divide both sides by 7. Let's get X by itself. Before you multiply, since you have X by itself, before you multiply or do anything else, reduce. Does anything cancel here? Yep. 7 goes into 63 how many times? Yes. 9 times 7 is 63. So 7 goes in there 9 times. So 9 times 5 is 45. That's your answer. There's another way you could have done it. Before you do anything, what is 63 made up of? 63. We know 3 goes in there. 3 goes in there 21 times. 21 is made up of 3 times 7. So to make these two equations equal, there's a 7 and there's a 7. What did I multiply to the left side? I multiply by 9, right? So I gotta do the same thing here, top and bottom. For them to be equal, they have to have the same multiple. 7 times 9 is 63. 7 times 9 is 63. So on the bottom, it has to be 5 times 9 or 45. You can use either of those two methods, and they always work. Let's try another one. 10 over X equals 2 over 3. There, and you'll turn in this one to me. And then on Thursday, I'll work it out for y'all. And whoever gets it right, I'll persist. We just had Valentine's Day not too long ago and Halloween not too long ago. I have a whole bunch of chocolate left. So whoever gets it right will get a piece of chocolate. So correct answers equals chocolate. That's an incentive. Finished? When you finish turning, you can leave. Why did you just staple a $20 bill on it?
Do you have an answer?
Now I'll work out real quick. Mhm.
I'll be here Thursday.
Yeah, another concert.
No, but Boston.
Oh, this is Boston. Okay, yes.
No Boston trip. So I was doing my test for the chapter 5,
Mhm.
and I accidentally like I have like my paper that I solved that out, but I put the wrong answer. And because it was supposed to be a fraction, but I don't know how I ended up being like a 4 and like 10 zeros. And I was like, how did that happen? But I didn't want to retake it because like I felt like I did good, but it was just like
There's a test.
Yeah, it was on a test. I don't know if you could go like
Yeah,
I can show you my work.
I missed it. Interesting.
Do you want me to tell you which ones?
It was one when you missed. When did you miss?
I just missed 2.
It's one that has all the zeros behind it.
And then there was, hold on, let me get.
Okay. Very good.
It was just these 2, it was like a fraction, and I put it in thing, so like,
How'd you do that?
I don't know. That's what-
You just rushed through because it was easy.
No, I don't know, and then I checked my. Test and I was like,
Okay, yeah, I'll change it for you.
I think.
You're right. Or maybe back something from Boston.
Okay.
Be safe. Have fun over there.
I leave on Thursday morning.
Have fun.
I have to wake up at like 3 in the morning. Yeah. I could like.
Yeah, but when you get there, you have the entire day.
Yeah, we're gonna get there like.
Yeah, that's just you get your money's worth.
Yeah, I'm gonna visit my friends.
That'll be fun. And take pictures. I want to see pictures.
Okay.
I love Boston. It's
Really?
the food. If you love seafood,
I'll try it out. I will see.
definitely try. Safe. Have a good weekend. Oh no, have a good week. I'll see you Thursday. Early Thursday.